All right, the 9-4 lesson essential question is, can I find the volume of cones and pyramids? And can I find the lateral and total surface area of 3D shapes? So let's get right into it. So the volume of a cone, like the formula for the volume of a pyramid, is volume is 1/3 base times height. Now what's different is that there's a 1/3 in front of there. So I have this little animation to show you. So here I have this solid, and if I unfold it to make it into a pyramid of sorts, I have it three pyramids. So I can go 1 cube, divide it into a pyramid. Doesn't matter where this top point is, it could be in the middle or on the side. It's 1/3 of the volume of the entire prism. So in this case, it would be 1/2 base, or 1/3 base times height, whatever base is from last chapter. So we're going to actually find the equation now, or sorry, the volume using the equation we just learned of this rectangular pyramid. So it's going to be 1/3 base, which is length times width times height. So I have 1/3 times 3 times 5 times h. 3's cancel. Oh, h is 6. And I have then 5 times 6 gives me 30. There's no units provided, so I'll do units cubed, and that's going to be my answer. So we're going to move on to surface area. So there's two types of surface area. Lateral surface area is the sum of all the lateral faces. Now, using the word in the definition isn't the best, but the lateral faces are going to be not the horizontal sides. So lateral, no horizontal sides or faces, other faces. So looking at this picture, this one's horizontal and the bottom's horizontal. So I'm not going to include that, not going to include that. This side, this side, this side, these faces, they're all vertical. So I would include all of these in my lateral surface area. The total surface area, well, that's everything. So that one's really simple. That's going to include the top and the bottom faces, the horizontal faces. What do we do if we have a shape that has slanted sides, like a pyramid? Which sides are which? So the horizontal face would be this one, the base, and these ones, well, they're not really horizontal, but they're not vertical. If rain falls on it, it would still get wet. What we're going to do is these sides, these curved sides, they're not horizontal. They're going to count as the lateral faces. So this side, this side, this side, this side, all the triangles, they would be the lateral surface area. And then the total surface area would include the horizontal base. So let's figure out how to make the equations for different shapes. So first, I'm going to sketch the base and the lateral faces of the cylinder. So the base and the top are circles, and then the side is actually a long rectangle. Consider this like a can of soup. There's that paper label. If I rip the label off, I can unroll it and make a rectangle. So now I want to add dimensions. Well, there's radius, the dimensions of the height of the can or the height of the side. And I've got this line here. And where is that line? Well, that line is around the circumference of my can. So this is going to be circumference times height. So to determine the area of each face, well, this is pi r squared, and this would be circumference times height. I'm going to change that to being pi, or 2 pi r, which is the equation for circumference, using that times height to give me the area of that. Now we're going to use our sketch to write the formula for total surface area and lateral surface area. So total surface area would be 2 pi r squared plus 2 pi r times height. And my lateral surface area is going to be just, not including that, not including top and bottom, just 2 pi r times height. Moving on to a rectangular right prism, sketch the bases, okay? So I'm going to have 2 of these little ends. That's going to be height times width. I'll put times 2 in there. I'm going to have 2 bases, which should be width and length times 2. And I'm going to have 2 sides, which would be length times height times 2. Area of each face, I'm going to have height times width, length times width, and height times length. And then how do I make the total surface area and the lateral surface area? Well, total surface area is all of these. So it's going to be 2 width times height plus 2 length times width plus 2 height times length. And then my lateral surface area is not including my top and bottom. And the top and bottom is length and width. So I'm not going to include this one. So it'd be 2 height times width plus 2 height times length. Let's change it up a little. Now the bases are shaded and it's laid on side. These are the bases. So determine the lateral surface area and total surface area of the right prism shown. The bases of the prism are shaded. So let's identify length, width, and height. So my length and width will be on the base, and my height is connecting the two bases together. Okay, now find the lateral surface area and total surface area. So lateral is going to be 22 times 4. That's going to be one of these faces. I'm going to have that times 2, one for this close side, one for the far side. And then the other one would be the same size, 22 times 4, but I was using this 4 for the first time. Now I'm using this 4 for the second one. So that's also times 2. So I can do 22 times 2 times, 22 times 4 times 2, and then times 2 again. So I'm going to get 352 units will be centimeters, and since it's area, it's going to be squared. Okay, why don't you pause the video and you find the total surface area. Okay, welcome back. So hopefully you remember that total surface area is the sum of the lateral surface area plus the two bases. Why is this going all weird on me? Getting blue. So, okay, let's leave it. Lateral surface area is what I found up here. The two bases would be 4 times 4 times 2. So that's going to give me a total of 32 plus the 352 will give me a total volume of 384 centimeters squared. Okay, here's another one. Let's try the surface area of a pyramid. So base, that's going to be simple. That's going to be 6 times 6. And then the surface area of these triangles, and if I draw it out, this is 6, this is it laid flat down, and the height is going to be this 7. Sometimes they want to be really mean, and they'll give you the height of the pyramid. If they do that, you have to then use Pythagorean theorem to find what's called the slant height. Slant height goes from the tip to a right angle at the base, and you need that for surface area. You need this measurement, which is the altitude, for finding volume. So this is going to be plus 6 times 7 times 4, because there's 4 sides. So let's get a little math done here. 6 times 6 plus 6 times 7 times 4 gives me 204, and our units will be meters squared. Moving on to some different shapes. Now, what about the surface area of a cone? Well, that equation is given us by the area of a circular base is given by the pi r squared. But what with the lateral face? You're just going to need to remember that it is going to be 1/2 times 2 pi r times s, where s is the slant height. Now this simplifies down to just pi r slant height. So this is a little breakdown. I have my cone. This is my base, which is this. This is, if I laid out and unwrapped the cone, it would form this triangular shape, which almost sort of looks like a sector of a sector of a circle. So I would just do slant height times radius times pi to get that one. Total surface area would be these two added together. So let's actually try it. So first it says determine the slant height. So the slant height, I believe, will be the 6.4 number. The radius is going to be the 10, but it's half of 10 because that's diameter. So radius will be the 5 number. This 4, we're not needing. It's part of the height of the whole cone. Apply the formula to determine the lateral surface area of a cone. So if I remember that from the last slide, it's pi times r times s, which makes this simple. Pi times 5 times 6.4 gives me 100.5, and the units would be feet squared. Okay, then I want to find the total surface area. Well, that's going to be this number plus pi r squared, with radius being 5. So that's going to be pi times 5 times 5 gives me 179.1 feet squared. Moving on to our last thing, spheres. A sphere is a dot with a radius that goes around in three-dimensional shape. A circle is that blue thing again. A circle is a point with a radius that goes around in a 2D shape, so sort of like a dog running around a tree. And then the sphere is the same dot, but now it goes all the way around, making a ball. We got some equations. The volume of a sphere is 4/3 pi r cubed. You just got to remember that. So let's try doing a problem. Let's find the volume of a 2.2-inch radius side. That's going to be 4/3 pi times 2.2 cubed. Put that in the calculator. And I get 44.5 5.6 inches cubed is volume. Okay, you pause the video and you try B. Hey, welcome back. So I have, this is my equation, 4/3 times pi times 4 cubed. I put that in the calculator and I get 268.1 centimeters cubed. Moving on to surface area of a sphere. Total surface area and lateral surface area are the same thing. The equation is 4 pi r squared. So you just got to remember that. So to do this one, I have 4 times pi times r, which is our 5.2, times squared. That equals, then put that in the calculator, 339.8 inches squared, because that's surface area. Okay, I want to talk about a little bit of extra credit options. So if you want to do extra credit because you've done all the stuff, you can do activity 1 on page 674 through 676, numbers 1 and 3. This is an activity where you figure out why volume of cones and pyramids is 1/3 of the total volume. So if you do everything else, you can do this, and you have to talk to me about it. And if you do it, you can get out these cubes that I have, and you can build pyramids that go progressively higher and higher, and figure some stuff out. So sorry that this video was a little long, but there was a lot to get through, a lot of different topics. So remember our lesson essential question: can I find the volume of cones and pyramids? And can I find the lateral and total surface area of 3D shapes?